Okay, good mornings to all of you. Uh, so today we will going to see about the revision of design of controls under the ergonomics and industrial safety chapters number 3. After this, manually material handling, and next point is the anthropometry. So what is actually the importance of these 3 points from the industrial point of view? So already we know that ergonomics, that is the certain laws we have to follow while doing the any work. So why this law is very important from the industrial point of view? So main purpose to follow the ergonomics principles in the industry so that man cannot feel any stresses, man will not feel any fatigue, his performance will get increased, efficiency will get increased, productions will get increased, productivity will get increased. If there is a no such ergonomic principles, then what will happen? We just will think opposite to this. If the in industry safety is not there, ergonomic principle is not there, what will happen? Main things, the productivity will become less. Why the productivity will become less? Because production is less. Why the production is less? Because the manpowers we required in industry, their efficiency is less. Why that efficiency is less? Because while working, the any types of works, because of that works, this man will feel fatigue and stresses will get involved in his body, and no longer he will continue his jobs. So examples in the foundry industry, lot of fumes are there, physically works is there, and dirty environment is there. So if we are not following the ergonomics principles, the workers, those are working in this foundry industry, forging industry, will not continue for longer time. So everybody should comfortably in their premises, and they will have to continue this 8 hour shift without any stresses, without any fatigue, and with comfortably manners. This is the main motto to study the ergonomics and industrial safety. If industrial safety is there, ergonomics principle is there, then and then the man will continue his work in that industry. If anybody will feel a stresses, fatigue, and there is a no safety, the man will not work uh, in that particular industrial premises. So here it is the need of the ergonomics and industrial safety. So first thing, uh, we have seen the design display, different types of displays are there. The man machine interaction, different types of displays are there. With help of display, the man will sense that display, then it will process that program is that sent to the machines. Machine operation will take place, and after that display will be there. So different types of displays we have seen, the qualitative display, quantitative display. In the what is actually quantitative display? Quantity will get certain value, temperature, pressure minute. Qualitative displays there. Here you will have to get different types of scale, fixed scale with movable pointers, fixed pointer with the movable scales. The different example also I have given to you. Your speedometer is there, temperature meter is there, voltometer is there, the CNC, VMC displays there. So these are the different types of display normally used in industry. After this, we have gone through the design of controls. Now, to control the machine's works, we required certain types of devices. For example, power press is there, forging machine is there, hydraulic machine is there, mechanical power press is there. So in this, all these presses are mechanical working machines. We have certain types of control device. Because of this, we will control that machine. For example, hand lever is there. To change the gears in lathe machine, hand lever is there. Hand wheel is there. So our the carriage is there. There is a hand wheels to control the movement of this carriage. Crank is there. In mechanical power press, offset part is there to control the torque. Knob is there. Voltmeters or current meter knob is there. Just by rotating clockwise or anti-clockwise, we can control the machines. Push buttons are there. So in electrical switches, push buttons are there. We can control this. Foot paddles are there. Number of machines we can operate or control by foot paddles. Mechanical power press, you can see the hydraulic as well as mechanicals in forging shops. There is a foot pedals to control the stroke of the machines. Joystick, this is the one of the sticks normally used in computer applications to control the various functions. Nowadays, it is replaced by your mouse system. So these are the design controls in the uh, industry so that easily we can control all these things. If this design control is not there, very critical to controls that machines, that process, or to apply the continuous force, then on-off situations, like these things, it is very difficult. So in ergonomics principles, the design display and design of controls, these two things are very, very important. Okay. So after this, we have gone through the manually material handling systems. So next point is the manually material handling systems. So what is this manually material handling system? So in this, many jobs or activity consist of manually material handling, such as loading, unloading of the different types of parts, removing materials from the rack, putting the material at particular height, then transfer of material from one place to next place. So these are the examples of the materials handling system. This manually material handling system, it is the one of the activity which will affect on the skeleton system of that man or workers. This manual material handling result in exertions, fatigue, stresses in a body itself. So if you see uh, the different the man skeleton system in the area. For example, if you go in the desert area, little bit different skeleton is there. If you go in Punjab sides, the big skeleton area is there. If you go the this east sides, the skeleton system is different. So in our military organization also depends upon regions to regions, the skeleton system is different. Accordingly, the different types of works it has been allotted and there's the specification of the body, etc., the selection process and the working hours, it has been decided. Okay. So this manually material handling systems, it plays important roles in industry, but this manually material handling systems, it should avoid as possible as otherwise there is a problems in the fatigue or traces of this. The main manual material handlings, the biomechanicals. So bio means your there is a mechanics. So biological approach. So it treats body as a system of links and connected. So our body having different types of link and different types of joints and different types are steel bands or the our hand band is there. So in this principle of physics, you deter the mechanical stresses on the body. Okay, so here the use of mechanics to decide the different activities and stresses developed on the body and muscles and force needed to counteract these stresses. So here's manual material handling. We have to keep the material at particular height. This is the manual material handling. But why there is a need to study this? Because only two regions are there. Two reasons are there. One is the fatigue. That man's will not feel the fatigue. Traces will not develop in their body. So, in order to extract these things from the manpower, so we require certain approach. So first approach is biomechanicals. Let us we considers our body. So our body having different types of joints, and these joints is connected by the link and connected uh, parts. And because of this, the work will be takes place. So biomechanical study actually we required to determine the mechanical traces on the body. So joint joint of the body, it will help to decide the stresses on the body, muscle needed to counter at these stresses. Suppose a small person is there and the height of machine is big, correct, and big person is there and height is accordingly to that man's machine height and man height is nearly about equal. So here little bit force is required. So here's you have to study about the biomechanicals means the hours body stresses and the fatigues. These two things will not be happens to anywhere because machine will not sells in specific area. Machine will send to all area. So we have to take the average of this. We have to study the biomechanical things, different types of joints, their capability, the operating things, so that in every regions the machines will operate easily. Correct. So that's why there is a main approach in the biomechanical approach. Mechanical means mechanics, and biological means the living things. We have to study about all our joints. Okay, and this actually requirements while designing the machines, ergonomically design of the machines. So that's why we require the biomechanicals. Okay, now different types of joints actually we require to study, and accordingly we'll go to the ergonomics. So this is the biomechanical. Biomechanicals means the use of mechanics to study. This is the use of mechanics. We study about the ergonomical principles, and accordingly we will go for design of the particular types of machine devices so that every regions this man's without affecting the traces or fatigue on the body he can work. Okay, now next thing is that is physiological approach. So what is that physiological approach? It is the actually how the body will work. In bracket I have written how our the body will work. In this approach it is actually concerns with energy consumptions and stresses acting on the our body. This approach is best applied in material handling activities carried out frequently over the sometimes. How your body will work, energy is required. Now, in order to work your body, energy is required. So physiopsychology means how your body will work. Energy is very important. Okay. A thin person, a weak person having less energy, and strong person having uh, good energy. But on an average, we have to decide this is the energy required to operate that machine. So here physiological approach means how our body will work. So we are walking, we are moving our hands. Accordingly, the design should be there. In their capacity, the human body need to work. And actually this body need to supply the energy while doing the any work. Then last approach is that physio-psycho-physically, psychophysically uh, theory is there in each mind and that particular man's behaviors need to study. Okay, mind setup and the work. So here's in these parts, it has been found that the peoples integrate and combines both biomechanical and psychological traces while the evaluation of the given traces, the use of psychological traces lifting the task, subject adjust then weight of load to maximum amount. These things actually we required. Means here's we required the combinations of both things, that is the biomechanical and physiological. These two things we have to combine, and it will become the psychophysical, means mind and behaviors. This is very important. Means if you sit in front of machines, more sound is there, more lightings are there, and this area is a little bit, suppose, a dirty area. So you will not work there. Your minds will not be able to work in that area. Okay, the clashes are there, or while working, some ego factor is there. So this environment is there, then there is effect on the ergonomics. So while working, minds and behaviors, this is very important, and this actually need to study while designing the ergonomics principles. Okay, so manually material handling system means loading and unloading, putting the jobs at particular height, lifting. Here we require the energy or some movement of our body. Okay, so if we combines all these things, then these 3 points that is very important. Biomechanicals means we have to study our the skeleton system by using this mechanics law. Then physiological, how our body will work. Then combination of both mind and behaviors will help in industry. Okay, so these 3 points need to study while designing the ergonomical any devices. Examples I have given to you. Once again, so I will give examples to our simple lathe machine. So biomechanical things, how we will study in a simple lathe machine. Let us consider the height of that machine. Okay, so big or the having little bit more height person, he need to bend while working on the machines. So his mechanics means working of the different joints need to study. At the same time, those height are very less. His body and his mechanics of working need to study, and we have to take at average height while designing the height of the lathe machine. So this is the biomechanical. Then psychologically, how your body will work. Okay. So whether headstock is left side or right. Why the headstock is not at right side? Why it is the left side? Why this carriage will move in the right to left? Okay. Why the check is moving at clockwise or anti-clockwise? So how your body will work? Accordingly, they have decided the tailstock should be at left hand side. The headstock should be left hand side. Tailstock should be right hand side, and so that machine will work. So how your body will work according to that machines we have to design by using the ergonomics principle. Then your working place, that is very important, because your mind is upset mind, then you will not work. Your efficiency will not be there. Your performance will be less, and unnecessary wastage of the times will be there. Then the behaviors with other people, if it is not good, clashes are there, not able to work. So this environment is there, and there is a effect in the material handlings or while designing the any devices by using the ergonomics. Okay, so material handling system, you have to remember these 3 points while loading, unloading, putting the any jobs to the particular height. You have to study the biomechanical things, physiological things, psychophysical things, so that there should not affect on the man's the fatigue and stresses, etc. So this is about the material handling system. Okay. So up to here it is clear. Anybody having any doubt? No doubt. Okay. Now, next, related to this material handling systems, uh, sometimes if we consider these 3 points, it will help to reduce the stresses, the fatigueness. We need to consider certain points in the material handling system. So under this first point, decrease the weight of job to be handled. Okay, if we studied these 3 points, and from this which thing actually we will get, first thing, whatever the material handling is going on, if the traces will develop, fatigue will develop in their body, the body will not work, his efficiency in performance will get decreased. So under such situation, if possible, you can reduce the weight of the material. Okay, so this is the first point. Second point, as far as possible, use of material handling devices to carry the load. Normally in industry nowadays, instead of the material handling done by the manually, here we can use the crane. The forklift is there, conveyor system is there. See that in sugar industry, conveyor system is there to move the material from one place to another. In big job is there, the your uh, steel manufacturing industries there, and your fertilizer industries are there, then your rolling mills are there. In this mills or industry, there is overhead cranes are there to handle the material. Here, we cannot use the mans. If you use the mans, these 3 points actually affect on the working conditions. Biomechanically, things always be there. Psychologically, the body, how this works, and the minds will not remain stable. The misbehaviors will be there. Some accidents will be happen also there. So next points, if possible or as far as we can make use of the this type of material handling devices in industry. Crane system is there, forklift is there for lifting purpose. Then conveyor systems are there in sugar industry. You can use this. Next, change the activity, that is use activity like push pull rather than carry. So sometimes workers used to carry that material from one place to another place. So instead of this, you can use a trolley system, push or carry types of trolley system, so that stresses on the body of the man's or fatigues will not get developed. Okay, then minimize the carrying distance as possible as you have to avoid the minimum carrying distance. If always there is a systems to carry the material from one place to the next place, that you have to avoid. Accordingly, you can design that layout, maybe process layout, maybe product layout. So minimum material handling system should be there. Accordingly, you can design. Then next is select suitable worker for carrying the loads. Okay. Suppose a pipe carrying unit is there, nearly about 20 kg weight is there. Accordingly, you can select the workers, unskilled laborers, more strength is there, since the brain is not up to that levels to work this his mentality while designing or everything. A specific person you have to select for this material handling. The skilled person should not be used for material handling. Okay. Do not use untrained or old workers. So suppose you are not trained any workers or worker is old, we cannot use for material handling. This point always you have to remember. Old person, anything will be happens while carrying that loads. And sometimes if you are not given training how to handle that particular loads, the according to that own his opinions, he will handle that material, times accidents will happen. To avoid this, you can uh, use the experience the worker for this. At the same times, you can give the proper material handling trainings or the loads to that workers. Offer the load according to the capacity. Suppose that man having capacity to carry the 20 kgs, why we can give him 30 kgs, 40 kgs. Capacity is very important. And job rotations to less the seriousness in the job. Sometimes if there is no alternative, you can change the jobs. We can one day you can give the work to some workers, next day you can give this work to other workers. You can change this, change for betterment. This technology you can use. So in this material handling system, you have to remember these 3 points, and what I told uh, regarding material handling. Very simple things are there. Here's trained workers actually we require as possible as we can reduce the job weight. Sometimes we can minimize the material carrying system. Sometimes we can use the material handling system. According to their capacity, we can give the loads. Okay. And the physically persons, those having strong and unskilled, as possible as we can give this work. Okay. And last one thing is that the main suitable worker actually we required to carry the this system. But nowadays in industry, instead of manually material handling systems, here's we can make use of the devices just like overhead cranes, then forklifts, then your uh, conveyor systems, so that we can reduce the stresses on the mind. But before going into that, these 3 points biomechanically, then these psychophysically, physiologically, this point actually we required. Otherwise, there is a effect on uh, the efficiency, performance, productions, and productivity. Okay, so here's the simple things are there. if you want to give this material handling systems to the particular person, trained person, that person should not be older, young persons, height adjustable, minimum carrying distance, okay, and according to their capacity, allowed that workers to carry these loads. So this thing you have to consider under the manually material handling system. Okay. No, anybody having any doubt, you can ask. We go to the next step. Any doubt is there, so you can ask. So one question is there, what is that biomechanicals? So this biomechanicals approach treat a body as system of links and connecting joint. Your hands or legs having joints, and this actually need to study. And in this principle of physics are used to determine the mechanical stresses on the body, muscle force needed to counter at the stresses. So here's you have to use this mechanics to decide the stresses developed in our various type of joint. Why there is need to study? Because we require to carry certain loads. Okay, if that body is not capable as per your joint, then joint sometimes it will become weak, sometimes it will break. Okay, our hand joint is there, leg joint is there, problems will develop. Okay, so according to your joints, the material handling system will be there. And physiologically, actually, while handling the material, the energy need to consume. Okay, so we have to study about the manually energy required to carry these materials. Okay, more than this, more energy is required, and if the energy is not in that man, definitely fatigue and stresses will be there. And combination of this both is this psychophysical things, minds. If any person is having the mind is upset or not feeling good to carry this material from one piece, mind setup is not this, anything will happen. So this is about the manually material handling. So up till now, from the last lectures, we have seen about the ergonomics, the main basic principle of the ergonomics. Ergo means our works and nomics means the laws. So this law, why this is a necessary? Because if this ergonomic principle, if we are not following as per the international labor laws, definitely the efficiency of the working or the performance will get decreased. Okay, so here we need to study about the design display and design control, because every machines there is a certain types of display, maybe quantitative, maybe qualitative. Design types of controls are there, maybe levers or hand levers or crank knob, etc. to control this. So all these things we have designs on the basis of the ergonomy. And what is the principle of principle? The law for work means you have to do your work as per the law decided by the international labor laws. Main purpose to decide this law, industrial safety, fatigue and stresses will not be there. Correct. So for these things we require the ergonomy. Machine height. Man height is 5. So machine height should not be 10 feet. Correct. So if you open your hands around 2 meters, the working area will be there. So within this area, you have to design the workplace. If you design the workplace more than man, will get traces, and once the traces will get developed, the efficiency or performance of that man will get decreased. To avoid this, we require to study about the ergonomics principle, follow the ergonomics principle, working laws we have to follow. Okay. Now next and last point in the chapters, that is the anthropometry. Anthropometry means science of humanity. What is anthropometry? Means science of humanity. In the last of this sentence, we are given science of humanity. What is this? Science of humanity means we have to measure the certain dimension of the body, certain dimension of the body. In military, there is a need of body mass index, height is there, and chest size is there. So accordingly, why there is need to measurement of this? Because this ergonomically, this person is capable to the work, that particular work in the military. If body measurement is not there, any person, if we take in that military, then that person will not work that what is the work of the military person. Correct. So here anthropometry means study of the humanity. Okay. So what it contain in the this humanity? So it is actually deals with the measurement of dimension, other physical characteristic of a body. Your dimension means height, chest, weight, and other physical character means center of gravity, volume, inertia, mass of the body, various segments of body. Okay, so this actually we require to study, because as per the ergonomics, if you are not going to study, then this type of devices will which will going to handle by the particular person, which is not able to handle, because the capability is not there. So here it's anthropometry means measurement of dimensions or certain physical characteristic of the body, such as the center of gravity, CG, inertia, mass, body mass index, or segments. Here, these measurements are actually two types of measurement: static and dynamic. Static dimension of the body consists of measured the dimension in fixed position. If you are standing at the fixed position, you have to measure this dimension, that is the static dimension. And it consists of skeleton dimension, dimension of joint, counter dimension, skin surface dimension. This dimension we have to measure under the static condition. And in dynamic conditions, dimensions we have taken in the situations when body is in working activity, when body is doing some work. Suppose we are lifting certain parts, we need to bend. Okay, so this is the dynamic condition. Okay, if we measured this dimension fixed positions, no any activity, then it is called static dimension. So in this anthropometry, we require to measure certain physical dimension of the body. It may be static condition or dynamic. Body mass index, this is very thing. I have given one examples of the military organizations. In military organizations, physical fitness, this is the one of the criteria. In this criteria, what actually we require to measure the hours, all things of body, height, weight, then eyes, chest. Why this actually we required to measure? Because this thing actually requires to be inherent in that person, so that that person will capable to work whatever the work of military persons are there, that work easily that man can handle. If this physical characteristic is not as per the specifications given in the military organization, then that person will not work, will not handle their responsibility when he enters into the military organization. So this anthropometry, this is very important to measurements of various part of bodies, so that we can decide the capability of the man, and accordingly we can develop the device or measurement. Okay. Now, basic applications data actually we required in anthropometry. First thing, some data is required in anthropometry. First thing is design for extreme individuals. Individuals, extreme individual. So in anthropometry, some dimensions we have to decide. Design, design extreme individuals. For example, our house window door is there. Let us consider door. House door is there. So why the house door height around 6 or 7? Why this is so? So here's while designing this thing, extreme individual dimension, average dimensions, and minimum dimension actually we required while designing the door of our house. So this dimension is related to the height of the person. Okay. So while designing the extreme individual, design for maximum population value is used if a maximum value of some design feature has to accommodate of doors. Designing for minimum population value is used if given minimum value of some design feature has to accommodate all. So here's a maximum and minimum extreme individual things we have to decide. Examples, our house door is there. What should be the height of this and how ergonomically it has been decided. So here, extreme individual and extreme, the minimum value we have to decide, and accordingly we can go ahead in this anthropometry. Because if we design for highest individual height of the doors, then minimum value means a less height person also will go. But if we design this height according to the less height of person, then high height of person will not enter. Enters, but he need to bend there and traces will get developed. So these points actually required to study in anthropometry. In industry, ergonomically you can design anything, but this anthropometry it is very important. Maximum, minimum value need to be considered. Then design for adjustables. While designing feature of equipments, machinery, there should be some adjustable thing should be there. For example, adjustable desk height is there, chair height is there. In our college, different types of chairs are there. Previously, fixed height chairs were there, but nowadays that chairs are adjustable. Means as per the requirements we can adjust. So this point also we required under this anthropometry. Then last thing is there, design for average. There is an average individual and person may be average on 1 to 2 dimension, and designer for the average also. Sometimes average things need to consider. So height is the basic part. But what about the width of the doors? Okay, Punjabi peoples and our Maharashtrian peoples, if you see that So if you design the width of the doors, which points need to consider an average or height or length. So here's always everybody will think that the both persons will accommodate or an average persons will accommodate. Sometimes both person, somebody will think that both person will accommodate. Somebody will think that average person will accommodate. And somebody will think that the the width should be also adjustable. Correct. So anthropometry is nothing but measurements of the physically dimensions of the body, so that it is very important while designing the any equipment, device or machinery facility. Uh, this dimension you will have to take at static or dynamic condition, and according to that, we have to follow these principles while designing the different types of equipments used in industry. Okay, which equipment? Now I have given certain example: the CNC machine height, VMC machine height, our door width, door height. Okay, cupboards are there. Two height cupboards. The smaller person, he requires certain support to take the any jobs from the top of the door. So here's while designing any devices, facility or machines, always you have to keep in your mind either you can design for maximum value, for example height. Maximum height you have to say 8 foot. Maximum height accordingly you can design any devices or the machine etc. So that minimum person will also, but the cost will get increased. Correct. Cost is also important. Everybody will think that if we design more than expected, what will happen? Because definitely the manufacturing cost or the capital cost also will get increased. So cost is also very important. The minimum, the average height, somebody will think, so that average person will enter. Somebody will think neither maximum, non-average, will go for adjustable. So example, adjustable chairs are there, adjustable desk are there. So average, adjustable, and maximum value. These 3 points actually need to be considered in this anthropometry. And for this, we require measurements, maybe mass, maybe the body width, maybe height of this chest, the center of gravity, inertia. Inertia, why this is required? Because while walking, whatever the path we have designed, that path need to sustain your loads. This is also very important. Various type of segments, levers, opening hands. So this measurements of body physically comes under the anthropometry. So this next name of this is the science of humanity. Science of humanity. Here need to study while designing different types of the devices, principles, machine, and so that why this much deep actually we need to go, because always we are thinking that while working any man, the traces may not be induced in their bodies, fatigue will not feel. If these two things will not be happens, the man's 8 hours efficiency or performance will remain constant. If the performance is good, more productions, more productivity, more profit will be there. So that's why we are thinking about this thing. Okay. So once again, I will review what is actually meaning to study about this ergonomics. The starting from the first point, ergo means work in Greek language, and nomics means laws. Certain laws we have to follow in industry, otherwise the problems will create. And this ergonomic principles given by International Organization for Labor. And in order to design these ergonomical principles, certain help has been taken uh, through the control systems, through the design display, through the material handling system, and through the anthropometry. Means anthropometry means your science of humanity. You can study about the humanity, and this will keep points in our ergonomy so that that device or instrument we can devise. So in the last, I will give one examples to you. Uh, our milling machine is there, adjustable stable is there, correct? If it is fixed, the smaller man's will not work, or heighted person he need to bend. So here's not maximum, not average, it is adjustable. So here's initially while designing the height of this milling machine, they might have used this anthropometry, uh, and through this study, this ergonomically milling machines has been decided. Uh, below this, before this, we have discussed about the point of material handling. Material handling may be handling by the mans, but again, if we handle this material by manually, then again we have to study these 3 point biomechanically, physiologically, psychophysically thing. And if we consider all these points, there is a definitely effect on the fatigue and stresses. So here's as possible as you have to use the advanced the devices or systems of material handling, just like overhead cranes, forklifts, as possible as you have to avoid the material handling systems in industry so that fatigue will not be disease, performance will be good. So this is about the anthropometry and material manual material handling system and design of controls. Okay, so next times we're going to see the design of workplace and the related points from the industrial point of view, maybe industrial safety or the working conditions, then basic principles of the industrial safety. This thing we're going to see. Up to here, sir, anybody having any problems, you can ask. In short, you have to remember while designing any machine, any instrument, any device, ergonomically you have to study so that fatigue and stresses may not introduced in a man. If introduced, less performance, less efficiency. For this purpose, we require the study of anthropometry, manual material handling system as possible as we have to avoid. Control system should be like that way. Display should system should be like this way. So ergonomically, you have to study the display system, control system, manual material handling system, and last one is anthropometry, that is the science of humanity. So here's we have to measure the dimension and physical characteristic of the body, maybe height, center of gravity, mass, the chest, all this property. It is very important while designing devices or any machines or any instrument. Otherwise, it will affect on the performance. So this thing you have to remember. Either you can go for average, maximum value, or it should be adjustable. 3 points you have to remember. While designing any machine, either you can go for maximum, depends upon your readings, physically readings. Okay, average value you can take, or you can go for adjustable. So next, parallel to this point, the cost is also very important. If you designs for maximum value and the customers are at the minimum value, then unnecessary the cost will get increased. Okay, so this point you have to remember under the ergonomics principle. Okay, so anybody having any questions you can ask within the 2 minutes. Any questions? No questions. Okay, we will going to stop here. So our time is over now. So we will stop here. Thank you once again to all of you.